Hi, so I'm testing this now. It's the dual rotor motor with a rotor of 16 magnets here and a rotor here and 8 coils with ferrite cores in the middle. The cores are wrapped 1/3 of their length with what I call a motor wind, and then 2/3 of their length with a induced generator wind. I call them pickup winds. Okay, so the coils are split. So for each coil there'll be 4 leads, one for the motor, one for the generator. So what I've done here is I'm only running the high impedance, the 2/3 section of the coils with power. I'm pulsing it in 16 times a revolution with this little Hall effect and these bidirectional MOSFETs. Okay, it's going 380 RPM. I checked that with a RPM meter. So right now it's running on 8.6 volts DC. It's running on around 20 milliamps. And I kind of looped it. I didn't think this was going to work, but it works. And what I did is took the output of the... Actually, I'm running the higher impedance, half or third of 2/3 lengths of the core that's wound. I'm using that as the motor wind. Okay, that's this here. Anyways, so the lower impedance is the generator winds. That's all I wanted to say. Sorry it took me so long to say that. So there's a higher impedance and there's a lower impedance of the coils to select from. The coils are all in series on the motor side and all in series on the generator side. And there's 8 of them. Okay, so anyways, so what I'm doing is running the generator coils through a full wave bridge rectifier right here, made of shottky diodes, SB350. And so I'm rectifying it into DC, the generator half of it, and I'm putting it into this 1200 UF cap bank. I've been using it a lot. Then, like I did in some earlier videos, I have the cap bank in parallel with the run battery, which is a rechargeable 9-volt battery. And so this cap bank is also the same voltage as this, the battery that's running it. So this is running off a battery with a cap bank parallel to it, and then it's the cap bank and the battery are being filled by the generator part of this dual rotor motor. Okay, so now why I say it's kind of looping is because when I put AC, a meter in AC volts across the AC side of the full wave bridge rectifier, it only says 2 volts. Okay, it's not saying like 12 volts or something. So then it would be like totally recharging itself. But it says only 2 volts on the AC side of the full wave bridge. So the AC side of the full wave bridge are the in and outs of the generator winds. So I don't know if you'd say in and outs, but the two leads from the generator winds of it. So, but I do know that the spikes come through those generator winds because they share a common core, ferrite core. And it's not lugging down from Lenz's law, and that's probably because it's only 2 volts coming out, but it is looped technically in that I'm filling up a cap bank that's parallel with run batteries from the generator winds. Now I don't have the a steering diode coming off the drain of the MOSFETs, you know, filling up everything, because when that usually will kind of short the thing out unless you do something where it's disconnected during the discharge, and that's where all those videos about the delayed switch, about 5 degrees retarded, and then I fill a cap bank and then I let loose the cap bank during the blank space and all that. I made a few videos on that. But I'm not doing that with this. I'm only doing the generator coil. Generator coils. 8 generator coils are going into the cap bank. So I think the spikes are coming through. And the voltage is holding up pretty good. But it's not going up in dramatic fashion or anything. But it is being looped right now. I could say that. And so my next thing to do, and I hope to do this tomorrow, maybe tonight, but I doubt it, is these switches. My last video, the purpose of these switches is going to be to short at the sine wave peaks these generator coils, the 8 generator coils in series. So I'm going to be putting another Hall effect right here, and right there on the AC side of the full wave bridge, you actually make a switch that will essentially short out what comes out of the generator coils just before it gets to the full wave bridge. And I do it very quick little pulse, and then right at the peak of the sine wave, which is going to be kind of like if it was a motor, the generator coils were motor coils, it'd be very similar timing to that peak of the sine wave. So I'm going to short the generator coils at the peaks next. And now you're not going to see this 2 volts here, you're going to see much higher voltage in there. And that's the next thing. So, okay, so thanks a lot for watching.